Hi everybody. Most of you probably won't need this, but this is just a little probability review. And I thought we would just go through it just in case you do. So I'm going to start from the very beginning. If we have an experiment, this is simply a process with uncertain outcomes. Okay, so process with uncertain outcomes. So it doesn't have to be as elaborate as, like cutting up a little lab animal or anything like that. So for instance, we could say if we toss a coin, that's an experiment. Okay? If, excuse me, if we toss dice, excuse me, that's an experiment because you don't know what the total's going to be. Okay? In the case of the coin, you don't know what side is going to come up, heads or tails. And in our experiments, we're going to assume that we have fair items. In the case of the coin, we have two-sided coins, that is heads and tails. They have not been tampered with. They're not weighted or anything like that. In the case of the die, by the way, die is singular of dice. Okay, again, it has 6 sides. It's fair. Oops, yeah, 6 sides. It's fair. It hasn't been weighted or tampered with or anything like that. Okay, so we don't know what's going to come up when we toss that die. All right, so that's an experiment. Okay. Of course, we just have 1, 2, 3, 4, 5, 6. It's a natural ordering. All right. So one of the things we like to do is take those outcomes and give them some kind of a numeric value. So I'm going to call this X. And I'm going to say, all right, I'm going to flip the coin. And if the coin comes up heads, I'm going to say X is equal to 0. If I flip the coin and it comes up tails, I'm going to say X is equal to 1. All right? Similarly, if I have the die, again, I've got that natural ordering. I'm just going to use that. I'm not going to be very creative here. Okay? And that's what I've just done when I take my outcomes and assign numeric values to them. That's essentially creating what's called a random variable. And let me write that in the bottom. Random variable. So I just take my outcomes, give them values, give them numeric values. Okay? All right, so what do you think is going to come next? So once I have my values, I'm going to assign probabilities to them. Yay, okay, no big surprise there. So I'm going to say, all right, I've got the probability of X, And in this case, the probability of having heads, when I flip the coin that it comes up heads, that is the probability that x is equal to 0, is of course 1/2. Similarly, the probability that x is equal to 1, the probability that that the coin comes up tails, is also equal to 1/2. Now those are all the possible outcomes, and we notice something interesting about that. If I add up all the probabilities, it's going to add to 1, which is as it should be. Similarly, in the case of the die, if I add up all the probabilities, all of those are going to go to 1/6, and if I add them up, the total will be 1. Again, as it should be. Okay, so that's pretty good. All right. And that leads us to some general case principles. So the probability of any particular outcome, the probability of x, is always between 0 and 1 inclusively, by definition. Okay, it can't be negative, it can't be greater than 1. And then, when I add up all my probabilities for my outcomes, it must be 1. Okay? And that's what we want it to be. So you're saying, well, what happens if the probability of x is equal to 1? Well, then you only have one outcome, and that's what it is. Okay, that is the probability is equal to 1. So you only have the one outcome. All right. Now, what we have just done, we have used what are called discrete random variables. I'm going to abbreviate random variables as RV. How did I know they were discrete? Because the x values were all integers. Now notice on these, the x's can be both positive or 0 or negative. Nothing wrong with negatives. All right? But you're not going to have fractions. You're not going to have decimal extensions, anything like that. That's what we have done so far. Okay? And when you get caught up in a second, I'll show you what happens in the continuous case. Okay, you ready? Good. So when you have variables that are not discrete, when you have continuous random variables, did I spell that right? Yeah. Okay. Then your x's are real numbers. So here you're going to pick up your fractions or your decimal extensions, decimals, things like that. There goes my dryer. So what you do in this case, instead of adding probability, well, let me put, say one thing. You're going to be integrating across probability. And don't panic. First of all, you'll have some kind of a probability function, and you'll integrate from A to B. Now, no integration in this class, so don't panic. Please don't panic. Are we going to be working with a continuous random variable? Yes, we are. It's called the normal curve. However, it is fairly complex to integrate, and we are going to be using the normal table. And it's in your book somewhere, probably in the back. All right? So you always integrate across the curve. You always integrate across an interval. You never integrate at one point. Similarly, and again, this is the analog from the discrete. If I integrate across a probability function from negative infinity to infinity, it's going to go to 1. This is like adding up all the values of x. If I integrate across the whole probability function, it goes to 1. Okay? All right. So that should give you a little bit of a warm-up, at least get you thinking about probability. And as I said, a lot of this should be familiar to you. If you have any more questions, let me know. Thanks.